Oh wow, look at this. I'm gonna learn the C programming language. What's this? Pointers? Okay, here's our memory. Let's create integer a. It's equal to 5. Then we create the pointer, which is ampersand a, meaning address of a. And there we go. Okay, I'll stop and explain it. Ampersand a means the address of a. So if you were to print that, you would get some memory address. You can think of the memory address like you would your house address. It tells you what position in your memory that thingy is. The little star symbol basically means dereference. It means literally point to and give me the value at. So if you were to print... Okay, sorry to interject. I made a little mistake. Okay, so let's say we have an integer a is equal to 5. Then we make a pointer, pa is equal to a pointer to the address of a. This line, all you're saying is you're declaring a pointer. This star symbol here just means you're declaring a pointer. Here, pa, that means dereferencing. So if you were to say star pa equal 10, it would make it so whatever pa is pointing to, which is a, becomes 10. Pointer pa equal ampersand a, so pointer pa, you would get the value at a, so it would print 5. It's really that simple. So here we have a pointer that points to a pointer that points to a pointer. You can imagine the diagram, it'll be literally the same. And if you were to change the value at any of these pointers, it would change the value at 5. If you say pointer, 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 PPPA is equal to 10, A will become 10. This is an array. It looks awfully like the memory. Arrays and pointers are very related. If you create a pointer that points to the array, we'll have a pointer that points to 1 in the array. We can then do this little syntax and iterate n up, and we can see if you print index, it will print the nth value. So in simple terms, this is the same as this. So pointers are pretty useful. One of their benefits is void pointers, which allow for you to have generics. As you can see, we have a void pointer here, and we want it to point to an integer. When we dereference it, we have to make sure to cast it to integer. This is like mainly beneficial when you're making data structures. So here we have a node. In it we have a void and a pointer to data, and we can cast it to integer. Cast data to integer. For all you chuds who use modern programming languages, this is how you would normally declare arrays. The problem is they're static. You can't change their size. It's set in stone. This is where pointers come in. So once you set a value, you can't change it. This is where pointers come in. By using the malloc function in the standard library, you can have dynamic arrays, meaning you can allocate a block of memory and then you can resize it as you want. When you've done this and you've allocated memory dynamically, you have to remember to free. Once you've allocated memory, it'll be there until you free it. And then make sure to set the pointer to null when you're done to avoid dangling pointers. The final big thing is passing by value and passing by reference. Normally when you pass in a value to a function, you pass by values. So it creates a copy of that value that sends to the function. So if you were to change the value passed in from the parameters, nothing would happen. It's a copy, right? Now, what if we use pointers? The pointers would point to the original value in your memory, which means it would change the whatever it's pointing to. So whatever you do in the function would change the actual values. Okay. So, in conclusion, that's pointers for you. Please like and subscribe so I can get a new mouse, cause mine is about to break. This video took way too long to make.